So right now we are going to write the a test bench for the square root. And it doesn't take any parameters, any ports, okay, as a test bench. Let's save it again. That's tb underscore sqrt .v. Okay. I'm going to instantiate the square root module. So this is square root, and then square root 0, for example. This is the module name. Then let's use the same scale because we don't have a way to override it. So these are registers. Again, register. And this one, wire and wire, right? These are observables, so they are wires. Now I have my always every, let's say, 10 clock cycles or 10 time units, I just invert my clock, yeah? And then in my initial block, first thing I do is to initialize my clock to some value, okay? And I'm going to activate reset. Dn is also 0. And also I'm going to go 0. I'm just going to set all the inputs, okay? All the inputs so that I don't get any don't cares in my waveform, okay? Now, here at the first positive edge of the clock, do nothing. Just let the reset takes place, okay? And then at the negative edge following this positive edge of the clock, deactivate reset. Okay? And I'm going to say, well, I want to calculate the square root of, let's start with, a perfect square, okay, which is 36 now. 36 has a square root of what? Of 6, yeah? شباب معي? Are you with me?
Yes.
طيب. So, but is this 36 in fixed point arithmetic with a scale of 12?
I don't think so.
Yeah, what's the correct way of doing it in fixed point? You need to scale this. You need to scale this by scale. Yeah, you need to shift this to the left by 12-bit in this case. Okay, because the fractional part here is 0. So this is equivalent to having 36.0. Yeah. In the previous, before we did that, before we did the shifting, the value was actually assumed to be 36 divided by 2 to the 12. Okay, which is not the thing. We don't want to find the square root of this number. Yeah, this number now is actually 36.0. And then I say, well, go equals 1. Okay. Once I give it go equals 1, actually, I'm going to let's have a negative edge here in the clock, because I just prepared my input now in this clock cycle. And then in the following clock cycle, I'm going to give a positive edge on go. And then I have to wait for the next negative edge of the clock. Okay. Now, at this point, algorithm should have started the computation. You remember here, once PE go becomes a 1, you start the computation. Okay, when do we stop? We stop. We know that the algorithm finishes when ready is 1. Okay, so I can say here at positive edge on ready. Okay, whenever, yani wait until you get a positive edge on ready. Okay, then just wait for 100 time units and then finish. Right, that's end begin. I think I already did that. And end module. Okay, great. But before I finish that, I want to actually create a waveform. Dump file. Let's call it square root .vcd, and dump vars 0, comma tb underscore square root. And this is the module name of the test bench. Yeah, I just computed the square root of 36. Okay, which should give me as an answer when we check when we get a positive edge on ready, D out should have what? Should have the value of 6. Okay, but 6 multiplied by 2 to the 12th. Okay, 2 to the 12th. Type save this, and then I need to go to the directory. Projects, square root. Okay, I think I can just copy this and then, well, CMD and then CD directory. Yes, this is the file. So I will invoke an iVerilog on the 2 files, square root V and TB square root V. Great, we have errors. Okay. So line 38 in square root.v, it says syntax error. Let's go to there. 38, where is 38? That's 38. Okay, end case. Yeah, we forgot end case. All right. Oops. End case. Maybe it's okay. So now a reference to a wire is not allowed. Oh, okay. 11, line 11. Oh, yeah. Okay, this is a wire. It's not I'm sorry. It's a wire, okay? Yeah, because this is an assigned statement. You cannot use a reg variable for an assigned statement. Okay. Let's do that again. Yeah. Okay. Great. Now I have my a dot out. So I can say VVP A dot out. It is taking more than, so it's not doing something. Okay, it's we can just check the waveform and debug. Okay, there is a logical error. Yeah, is that GTK wave? GTK wave. Square root BCD. So here we have the clock. Can add that. Nothing happened. Why? And what? No. Well, something is fundamentally wrong.
دكتور ممكن الأولويز ما سويت لها المفروض نسكره ولا سكرته؟
Yes, I did actually close it. Yes. No, but the clock is not showing it whatsoever. See, there is something wrong here. Always. Okay. Okay, so instead of this, I'm going to just wait for 1000 time units and then finish. Okay, regardless of whether ready is 1 or not. Okay, so this is going to give us at least a waveform to play with. Okay. Oh, I think I need to close this. Oh, I see why. Okay. It's because the file is huge. You know, because it's we haven't stopped it, and it seems to be. Let me just try to force quit. Okay. All right. So now I Verilog again. And okay. And then GTK wave. Yeah. If I append this, it's not working. I don't know why. And if I close it, maybe because I think it's something related to the dump file. Okay, maybe dump file. Let me pause the recording and then investigate the error and then get back to the video again. So after compiling using Model Sim, we discovered that the order at which you place the assigned statements does really matter. Okay, it does really matter. You have to, for example, in order to use state, you have to, in an assigned statement, you have to actually place it after defining the the state or after declaring the state register. In order to use X, you have to define it before using the variable, before using X, okay? You have to declare X before using it in an assign statement. Here as well, S by X is using the state and it is using X. So both of which are defined already. So after that, we can now go, I mean, also, there was an error in the test bench and also the square root, okay? This error was that we assumed that the reset is active low, but it was without the not, okay? Yani, the statement was if reset underscore n, and this is an active high reset actually. If this was the case, then this is the inactive reset, and this is the active reset. So the circuit from this point on, it is on the reset state forever, okay, until you finish. So it doesn't really work. So in order to fix that, we need to make sure that this is actually active low reset, okay? And also, yeah, that's the error. So let's go to the prompt and try to compile and then run or simulate, and then open up in gtkwave, okay? So you open up in gtkwave, you can actually add all of these signals together. And then here, by the way, data in and data out, you want it to be actually in decimal, and you want it to be in what we call fixed point, yeah, fixed point. So we go to fixed point, shift, and make sure it's on for both. And then you have to specify the number of bits at which you shift, okay, the scale. Yeah. Once you put that, okay, and here as well, you see that 36 now is shown here, specify 12. Okay. You see here, you just calculated the square root of 36 to 6, okay? Just to make sure, to give you to give you a better test case and to show you the fixed point arithmetic in action. Let's calculate the square root of I don't know, maybe 2, square root of 2, yeah, which is using the calculator now. Let's just compare our calculation with the calculator. So 2, and then that's the square root. There's a 41421, okay? So I just changed that data into 2, and then we'll see what happens when you compile, and then run, and then open up in gtkwave, okay? Not again. There's something wrong. I think there is something wrong with I don't know what's wrong, but there is something wrong with gtkwave. It's not uncertain.
Doctor, I think you have to append all signals.
Append all signals? I did.
Yeah.
I did
No,
that.
look at the signals column.
That's a
There is only
parameter.
the
It's not a signal, that's a parameter. This one is a scale. But it's really very weird that okay, let's try do that again. Right. All right. It doesn't really calculate that. Let me change this just for the sake of no, okay. So let us try to debug just after at the negative edge of the clock, and after 1000 time units, just finish without waiting for ready. Okay. Let's compile this and simulate it. No, it doesn't work. We have to go back to model sim and see what's wrong. So anyways, I'm not going to make a video much longer. Let's stop here. Okay, and we'll do my investigation privately. Okay.